Hello and welcome back. Our topic today is double triangle problems. So we've been hitting these law of cosines and law of sines pretty heavy, and you're going to see them again today. Now these are all very wordy problems that involve two triangles, hence double triangle problems. So here's our plan of attack. So let's go ahead and get this in our notes. First, you want to identify all angles and sides possible. Once you've done that, your second step is to find the side that they share first. And that's huge. You've got to get that one that they share first, and then you can go answer the question. Alright, so you definitely have, when you have two triangles, you definitely have to do two problems. Okay, so again, these are wordy and they're a little on the long side. So pace yourself tonight. Before we dive right in, you're going to see the words angle of elevation and angle of depression pretty often. So let's go ahead and get a picture of what we're talking about. And I think the Z idea, the alternate interior idea, will help you. Angle of elevation, well, think of if you hurt your leg and your doctor tells you to elevate it. They're telling you to lift it up. So basically, the angle that you make when you lift something up is the angle of elevation. So that is this inside angle here. Now, depression doesn't mean to lift up. Depression means to look down. If you depress your head, you're looking down. So that would be this angle up here. So picture you just kind of looking down, and that angle that it makes is your depression angle. So always just make your Z, and I think it'll be easy to tell your angle of elevation and angle of depression. So I'm going to read these very slowly, and I'm going to stop often and draw what the picture's saying, and I think that's the key here. A 40-foot high sign is placed on top of an office building. Let's stop and draw that out. So I'm going to use this line to represent my office. And it says a 40-foot high sign is placed on top of the building. So I'm going to switch colors here. I'm going to make a point here and say, this is my 40-foot sign. They're putting it on top of this office building. From a point on the sidewalk level with the base of the building. Base of the building, of course, means the bottom of the building. So from a point on the sidewalk level with the base of the building, there's my point. The angle of elevation, there's that key word, to the top of the sign, and the angle of elevation to the bottom of the sign. So picture this is your head, and you look up to the top of the sign. So you look up to the top, and you look up to the bottom of the sign. Are 45 and 33 degrees respectively. Respectively means in order. So the one they said first is 45, the other one is 33. So let me read it again. The angle of elevation to the top of the sign, so picture your Z. You're going from the bottom up, that's the elevation. So you've got to be starting bottom up. That whole angle is 45 degrees. And then just to the bottom of the sign, just that angle in there, is 33 degrees. So maybe you need to stop and just read it to yourself and redraw the picture. Half the battle is drawing the picture. Once you get that, the math isn't that hard. It's really just drawing the picture on your own. So now here's the question. What is the height of the building? So I'm just going to put my X here of that office building, and that's the side I'm actually looking for. Now, do you see the double triangle problem? And it actually is like a triple triangle. There's actually 3 triangles, but we're going to do math on the 2. There's this obtuse triangle, okay, with this large angle here. And then there's this triangle right here. So there's your 2 triangles. Now technically the big one makes the 3rd triangle, but we're going to focus on these 2 triangles. Now, if you flip back to the directions, I said the first goal should be to find every side and angle possible. That's the whole key. So think about an office building. If you were to make a building, you would want to make sure your building is very perpendicular, is straight up and down. So they're going to assume that you understand that your office building is perpendicular to the ground and it makes a right angle. They're not going to tell you that. Okay, they want you to assume that that's a perpendicular building, that it's standing straight up. Now, that's extremely helpful because I can get every angle in this picture. Alright, so I want you to focus on just this small triangle. Alright, I know this angle in the triangle is 90. in this triangle, this small angle here is 33 degrees. Can you get this angle? Well, remember, they all have to add up to 180. And if this is already 90, basically these two have to add up to 90. So all I'm going to say, and I'll write it out anyway, to get this angle x, I'll call it x for the moment. I'm going to say 180 minus the 90 minus the 33. So that gets me an angle of 57 degrees. Okay, now can I get this major angle up there? Well, I'm going to focus on the big triangle now. Okay, so I've got x here, I've got my 90 here. What is the angle of the big triangle? Hopefully you're saying 45. So I can say, okay, that's 180 minus 90 minus 45, which gives me an angle of 45 degrees. Could you get, I'm going to put a little sliver in here, could you get that angle? Well, think about this. The whole angle is 45. This piece of it's 33. Could you get that little sliver? Well, hopefully you're saying, sure, it's just 45 minus 33. So I would say that's an angle of 12 degrees. And notice that should total 45. All right, I've got one more angle to get, and I'm going to put my x here this time. This is a property we haven't talked about yet. If two angles are next to each other and form a straight line, so again, back to your geometry days, they're called supplementary. One's obtuse and one's acute. Those two add up to 180 also. So to get that angle, I should just say it's 180 minus 57. So I get an angle of 123 here. All right, so step one is so important that you take your time and you find all the angles possible. Now, go back. What did step two say we had to find first? Remember, we want to find the side they share. Well, if you look at this triangle and this triangle, I overlapped them once. Let me do it again. This part and this part. Notice I went over this side twice, so I want you to put an X there. We have to find that side first. Okay? So all that work we did was just to get the missing pieces. I now have to get that side first. And here's what I do. I always work in the triangle. Let me say this. Work in the triangle where you have the most information. And that's going to be this upper triangle here. Okay? This is what I eventually want to get. I can't get it yet. It's a double triangle, so there's two triangle problems. I'm going to work in this one up here. So, which laws are you staring at? And if it's too messy for you, pull it out like I did on those other vector problems. I know this is 40. I want x. I know this angle is 123, 45, and 12. So, now it's a little slanted, but 40 is across the way from the 12, and x is actually across from the 45 degree angle. So I've got law of sines. So I'm going to say the sine of 45 over x, and the sine of 12 over 40. You can do the math from there, cross multiply and solve. And so pause it, try it on your own, see what you get. We'll see if we get the same thing. I get x to be 136.039, etc. Now again, that's not my final answer, so I'm taking that answer and I'm storing it into alpha A. Okay, that's the side they share. That's what you find first. Now I'm going to put, my 136 there. I'm going to put big alpha A there that I found it. Alright, so now I'm going to work in the triangle where I actually want to get the answer. I want side x. And side x is across from 33. And this angle A, or side A that I found is across from 90. So I've got just another law of sines problem. So I'm going to say the sine of 90 is across from A that I found. And the sine of 33 is across from x that I want to find. Cross multiply, solve, pause it, see if we get the same answer. And I get x equals 74.09, so we'll say 74 to the nearest whole number. So that building is 74 feet tall. So we've attacked our first double triangle problem. A lot of work, but remember, just find all the missing sides and angles first that you can, and the rest should be easy. Find the side they share, and then the one you want. Question 2. From point A on the bank of a river, okay, so put your pencil on point A, that is where you are starting. The angle of elevation to the top of a tree is 45 degrees. So remember that z. And clearly the z could go, whoops, the opposite way. The angle of elevation is the one that looks up. That's your elevation, so elevation could be here, is 45 degrees. So if you're standing here looking at the tree and you look up, hopefully you're saying that is your 45-degree angle. As shown in the figure below, point B is 100 feet behind, which they put it in there for you, and is in the same straight line as point A and point C. From point B, so now I put yourself on point B, the angle of elevation to the top of the tree, so you look up, it's 33 degrees. Find AC. That is the one they want you to look for, to the nearest foot. Alright, so step 1, double triangle problem. I hope it's obvious that there's this triangle, and then there's this triangle. Find all the missing sides and angles that you can. Okay, so that first rule said I need to find every angle I can. And I think, again, you can get them all. So again, they're going to want you to assume that, like a building, a tree is perpendicular to the ground. Okay? So let's start with that triangle where the tree is. I've got a 90 and a 45. Can you tell me what that other angle is? Remember, all three add up to 180. So if you do the math, hopefully you get a 45-degree angle up there. Now remember, these two next to each other make a straight line. This angle and this angle. So that means they add up to 180. So if I do my 180 minus 45, I should get an angle of 135. And now I can get this angle, this little sliver up here, because notice I have 135 and 33. If I add those and subtract from 180, I get a tiny little slice of, whoops, 12 degrees. Okay, so I found every angle in the picture I could. Now our second rule in double triangle problems is to find the side that they share. So I need to get this side first before I can go and get the answer to my question. So find the side they share. So notice, since the real question is in this triangle, I'm going to use the other triangle to get that side. Let me say that again. The real question is this triangle. I have to use the other triangle. So let's see what we've got. Do we have law of sines or law of cosines? Well, I have 100 feet, which is across from that little sliver, 12. And I've got x, which is across from 33. So it's definitely law of sines. So we'll set her up. That's the sine of angle 12, and its partner across is 100 feet. And then the sine of 33, remember the trig function and the angle go together, is across from x. So pause it, do the math, see what you get, and we'll compare. I've got an answer of 261.9569, blah, blah, blah. Now remember, I can't round that answer because it doesn't actually answer the question to the problem. So I'm storing that in alpha A. Okay. So now I'm going to use my other triangle. So let's see. I have this x value that I want to find, which is across from 45. And I know this value. This is what I got for A. A is across from 90. So I'm going to say the sine of 45, which is across from x, what I want to find. And let's say the sine of 90, which is across from alpha A that I just found, that 261 number. So again, pause it, try it on your own, see what you get, and we'll compare. I get an answer of, to the nearest foot, it's at 185 feet. And there you have it, double triangle problem. All right, here's another really common question. A man at one point on the street, so let's start with a man on the street, finds that the angle of elevation to the top of a tower is 30 degrees. So he's looking up to this tower. So again, everything's just going to be a straight line. We know we're going to end up with triangles. So you need the ground, and he looks up, and that angle that he makes is 30 degrees. After walking toward the tower for 150 feet, so he's going to walk toward, I don't know where that is exactly, but I know he walks 150 feet. On that straight line, he finds that at the second point, the angle of elevation is now 68 degrees. So he looks up to the tower again, and he's got to look higher. He's got to stretch his neck out a little more, so it should make sense that that angle's bigger. What is the height of the tower? So there's my x, to the nearest foot. So again, once you have the picture drawn out, I don't think it's too ugly. So your goal is to get every missing side that you, or missing angle that you can. Now remember that tower is perpendicular to the x-axis. So pause it, try it on your own, see if you can get all the angles, and then we'll compare. Pause it and see what you get. Alright, see if you like what I have. Real quickly, just to be clear, these two have to add up to 180, so I took 180 and I subtracted 68. Once I knew these two, I added those together, subtracted from 180 to get my 38. These three had to add up to 180, so I added those two, subtracted, and got my 22. Alright, double triangle problem. So even though I want this x over here, I first have to find the side that they share. Find the side they share. So because I want the side they share, I'm going to use the other triangle first. So again, I want this triangle for my final answer. I'm going to start with the other triangle. So let's see what we've got. I want side x, which is across from angle 30, and I have 150, which is across from 38. So hopefully you see law of sines. So I'm going 150 is across from the sine of 38, and side x is across from the sine of 30. So again, pause it, try it on your own, see if we get that same value. I got an answer of, was it 121.8 something? 820, blah, blah, blah. That's not my final answer, so I'm storing that in alpha A. Storing to alpha A. And now I'm going to go get the question that I really want to answer. And let me remind you, that was to get this side here. So this x is across from 68. And this x is now my alpha A. A is across from 90. So my second triangle problem, side x is across from the sine of 68. And alpha A is across from the sine of 90. Cross multiply, solve, and I think it's said to the nearest foot. So I've got x equals 112.9, which I'm going to round up. I better just double check. Did it say nearest foot? I'm going to round that up to 113 feet from my tower. Alright, well, last question for the night. The accompanying diagram shows the plans for a cell phone tower that is built near a busy highway. Find the height of the tower to the nearest foot. So here's my tower. I'm going to put my x there. So I drew the picture out for you. And again, I'm going to let you pause it, do this one completely on your own. Find all the missing angles. Then I'm going to put an x. We're going to find the side they share first. And then we'll go get our answer. So pause it, try it completely on your own, and then I'll work my solutions out. So hopefully your angles match with mine. So you can follow my work. I set up my law of sines problem. I circled my opposite sides, and I've got this middle value which I'm storing into alpha A. So again, I'm going to put a big A on this side. That's what I found that to be. And I'm going to set up my next problem to find the tower. And again, I've got my work off to the side there. Hopefully you followed and got the same thing. And it said nearest foot, so I'm going to round that tower up to 33 feet. Well, there you have it. So the whole trick to the double triangle problems is to find all the missing angles, find the side they share, and then go get the one you want. Have a great night. We'll see you tomorrow.